Don't guess as to whether or not your board will have thermal issues. Export to Hyperlink's Thermal and run a quick simulation to get an idea of what to expect. Default component dissipations do a pretty good job of estimating the thermal profile of the board, and more detailed models can be added at any time for increased accuracy. All simulations use 3D models including the component height, so that the effects of airflow through the board get properly modelled. You can analyse potential solutions to thermal issues by adding heatsink, screws or wedge locks that connect the board to the thermal chassis, or airflow changes to name but a few. So let's take a look at thermal analysis and how to address thermal issues through simulation. With a complete or even partially routed design in PCB, exporting the board for analysis is as simple as selecting the Hyperlink's export from the Analysis pull-down menu. All relevant information for all analysis types is generated, including three-dimensional models that provide component height for thermal analysis. Once in Hyperlinks, you can immediately launch a thermal analysis. Of course, it will use the default power dissipations for the components, unless you have already assigned them to your parts, but it will still give a pretty good estimate of overall thermal performance. In this analysis, you can see that one component is much hotter than the others, so the most obvious fix is to add an heatsink. I can place one on the hot component and then resimulate. It has the desired effect of cooling down the hot component, reducing the peak temperature by about 12 degrees. There are a number of different thermal solutions that can be investigated, including connection to a metal chassis through board edge connections or mounting screws. Carefully placed mounting screws can provide a path for conductive cooling, and are especially effective when the board contains a large number of solid power and ground planes. In this example, the mounting screws help reduce the board temperature even further. Proper modelling of board conduction, radiation for both natural and forced convection are all included in the analysis. Three-dimensional models of the components, including component height, are used to model the effects of airflow perturbation and the heating of cooler components from hotter upstream components. All of the traces, planes and vias on the board are also included in the analysis to properly model heat conduction throughout the board. The board ambient conditions can be parameterized in the environment settings windows, so that changes, such as modifications to the airflow, can easily be made and the results reanalyzed. Here you can see only a small change from the effect of the increased airflow. Hyperlink's Thermal arms you with the information needed to intelligently make design trade-offs. As you can see, Hyperlink's Thermal makes board level thermal analysis easy and accessible. It allows you to head off potential thermal problems early in the design phase, with results that accurately predict real-world performance.